I mean, we already added vectors. We added them in the component form. We added them when they were linear combinations of the standard unit vectors. How did we do it? You add the first components, you add the second components. So in order to do the same thing in this problem, we need to break down the V1, the plane, and the V2, the wind, into its components. And then we'll add the first components and add the second components. So I'm just copying their work in there. That's what I'm showing here. So the first vector, right, it has a magnitude of 500. So we're using that format of saying the magnitude times the component form, cosine of the direction angle, sine of the direction angle. And 120 degrees, that's unit circle. So you can see here they use the unit circle coordinates. Honestly, if you just turned it into a decimal, you're fine. I mean, they do by the end. But yeah, they take into account the 120 as the unit circle value. And we know 120, that would have been negative 1/2. So negative 1/2 times 500 is negative 250. And the sine of 120 is positive root 3 over 2. So that's where you get the 500 over 2 is 250 and the square root of 3. So there's the component form of the plane. Then we do the same thing with the wind, 70, speed of the wind, cosine of 45, sine of 45. And we get these two components. Okay, how do we add up V1 and V2? Add up their components. Right? Add up negative 250 plus 35 root 2. That's this right here. Then add up 250 root 3 plus 35 root 2. That's this. Again, you could just turn it all into a decimal. If you did that, you get this component form of a resultant vector. Right, this is the resultant. Okay, if that's your component form of the vector, how do you know the speed? How do you know the magnitude of it? Can you do that? The square root of the first component squared plus the second component squared. And you get 522.5. So actually the wind is speeding this thing along a little bit. And how do you find the direction? Tangent of theta equals 482.5 over negative 200.5. Now when you do that, I don't like the way they've written all this, but if you take the arctan or the tan inverse of this fraction, you get negative 67.4, right, which would be down here. Now we know that our plane is up here and the wind was like that. Our resultant vector is something like that. So our angle is definitely not down here, is it? But remember, how do we find another place where tangent has the same value? You add 180, right? It's always straight across the circle. So if it equals that at negative 67.4, if you add 180, you're going to find the angle that we're looking for. That's what they do there. There's where the 112.6 comes from.